All right, today we're diving into something pretty wild, the blueprint for an autonomous drone swarm. We're going to break down how a whole bunch of independent robots, with absolutely no one in charge, can actually learn to think, decide, and act, almost like they have a single intelligent mind.
I mean, just think about that for a second. How does a team of robots make a life or death call with nobody in the driver's seat? Picture this. You've got valuable assets on the ground that need protection, right? No central command, no human pulling the strings in the moment. And then, bam, a threat appears. Who does what? How do they decide? That's the exact problem we're going to get into.
Okay, first up, the mission. We're talking about autonomous guardians. So let's set the scene here, because we're not just talking about some abstract code on a screen. This is a plan for a real team of, well, autonomous guardians. Their job? Protecting critical stuff on the ground. The stakes really couldn't be higher. Now, before we get any deeper, let's just make sure we're on the same page with this term autonomous swarm. What we're really talking about is a group where every single robot, every agent, is making its own decisions. There's no puppet master. The smart, coordinated behavior you see, it's not commanded from the top down, it just emerges from the simple rules each one of them is following. It's pretty amazing. So, how does the mission kick off? Well, it all starts with prep. First, the swarm figures out, okay, what are we protecting? The assets get identified and prioritized. Then, our friendly drones get into their patrol positions and fire up their sensors. And right here, at this moment, every single drone is building its own little picture of the world around it. You know, where am I? Where are my buddies? And what am I supposed to be keeping safe? Section 2, the first glimmer. Detection. Okay, so the stage is set. The swarm is on patrol, everything's quiet, and then it happens. The system gets that first little hint that something's not right. Suddenly, an unknown contact pops up on their sensors, entering the airspace. And that's the trigger. The second that happens, the logic inside every single drone just kicks into overdrive. This isn't one big brain seeing a blip on a radar. It's a bunch of individual minds all seeing it at the same time. And here's where it gets really cool, the uncertainty. Look at this. Based on what its sensors are telling it, each drone makes its own call, but it attaches a confidence score. So it might be thinking, I'm about 45% sure this thing is hostile, but I'm not totally certain. And that ability to deal with ambiguity is absolutely mission critical for how the swarm makes its next move. So let's talk about how this thing actually thinks. Okay, so how do you get from a fuzzy, maybe this is a threat, to a concrete action? Well, to figure that out, we're going to zoom right in and look at the thought process of just one drone in this swarm. We're going to see how it actually thinks for itself.
It all boils down to this really simple but super powerful three-step loop. First, it perceives. It sees the contact with its sensors, easy enough. Second, it assesses the threat. And this isn't just a simple, is it friendly or not question. No, it's asking, how dangerous is this thing to what I'm protecting? It's calculating speed, heading, ETA to one of our assets. And then finally, it decides. Based on that whole threat score, it comes up with a list of options. Should I go intercept? Should I go help a buddy? Or should I just stay here and guard?
And this really gets to the heart of the logic. The number one priority is defense. A threat isn't just about what it is, it's about what it's doing, its intent. The plan is clear. Any contact that looks like it's making a beeline for something we're protecting gets flagged as high priority right away. And that is what triggers a much more aggressive response. All right, now for the main event, coordinated strike, no commander. So this individual thinking is what builds up to, honestly, the most incredible part of this whole system. You've got all these drones. They've all got their own little assessments, their own lists of what to do. So how on earth do they coordinate an attack when there's no commander calling the shots?
Okay, this right here, this is the secret sauce. The blueprint lays out two different ways to do this. First, if their communications are working, they basically hold a super fast auction. Every drone broadcasts how good its position is to intercept the target, and whichever one is closest or best positioned wins the job. Simple. But what if their comms get jammed? This is the brilliant part. They just switch to a shared rulebook. Without a single word being exchanged, every drone follows the exact same strict rule. For example, the rule could be the closest drone engages. If there's a tie, the drone with the lower ID number goes. This guarantees they act as one, even in complete radio silence.
So using one of those two methods, the whole swarm instantly converges on a single plan. The winner of the auction, or the one picked by the rulebook, calculates the perfect intercept trajectory and moves in to neutralize the threat. And the key thing to remember here is that this decision wasn't handed down by a leader. It just
emerged from the system itself. Now for the blueprint of an AI swarm. So this whole mission we just walked through, this isn't science fiction. It's the actual end goal of a very real, very detailed engineering blueprint. So let's pull back the curtain a bit and see how the developers actually plan to build this thing from the ground up.
You don't just build something this complex all at once, right? You do it in layers. And the plan lays out a super clear roadmap. You start with the absolute basics. Phase 1 is just building the simulation world and getting the physics right. Then in Phase 2, you add the drones themselves and their sensor logic. Phase 3 is where you build that threat scoring brain. And only then in Phase 4 do you start adding the comms and the actual swarming behaviors. You finish up with the visuals and testing. It's a really logical, step-by-step path from a blank screen to a fully thinking swarm.
And you know, big ideas like this always have to start small. The plan calls for what's called a minimal viable prototype, or an MVP. This isn't the giant final swarm. We're talking maybe 5 friendly drones against 3 hostiles. They've got simple sensors, really basic engagement logic, and just a simple 2D display to see what's happening. And this is how you do it. You prove the core idea works on a small scale before you commit to building out the whole shebang. It makes a huge project like this feel way more manageable.
And that's really the main takeaway here. It's all about this connection, this incredible, almost intelligent-looking behavior of the swarm. It's not magic. It's born from a really clear step-by-step engineering blueprint. It's all about creating simple rules for the individuals that lead to complex, coordinated action for the entire group.
Which of course leaves us with one final and much, much bigger question. We've just seen the blueprint for how a machine can learn to think and act as a group. So, as these systems start moving from the drawing board into our world, you have to ask, when a swarm of machines makes a critical decision all on its own, who is ultimately responsible for what happens next? Definitely something to think about.